আপনারা দেখছেন পিবিইউ নিউজ, কোচবিহার পঞ্চানন বর্মা বিশ্ববিদ্যালয়ের নিজস্ব ইউটিউব চ্যানেল।
Myself, Dr. Siddhartha Sankar Laha, Coordinator, Department of Economics, Coochbehar Panchanan Barma University. Today I take class on 4th semester students in economics. My discussion on today, introduction of hypothesis of testing. Now I start my class according to my PowerPoint. Thank you. Today my topics, introduction to hypothesis testing. Basically this is the in social science topics used in economics also. This is the part of research methodology for 4th semester students. In this chapter we learn to use an inferential method called a hypothesis test. Number 2, to analyze evidence that data provide, and third, to make discussion based on data. First, what is the basic definition of statistics? Basically, statistics is a collection of methods for planning experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting and drawing conclusion on our survey data. Next, in statistics, how many types? Basically, statistics mainly 3 types. Basically, in broad sense, this is basically 2 types, and this is a transformation case. First, descriptive statistics and inferential statistics. Here, descriptive statistics. What is descriptive statistics? Descriptive statistics, a brief description of coefficient that summarize a given data set. Suppose example, measure of central tendency like mean, median, mode, quartiles, percentiles, etc. Second, measures of dispersion, deviation, suppose mean deviation about mean deviation about mode, mean deviation about median. Standard deviation, variance, range, coefficient of variation, skewness, kurtosis, etc. Basically, these 2 measures, 2 types of measures we discuss in graduation levels. Here, inferential statistics. Inferential statistics is a statistical method that deduces from a small but representative sample the characteristics of a bigger population. Suppose, for example, linear regression analysis, analysis of variance, ANOVA, that's ANOVA, MANOVA, and analysis of covariance, statistical significance, suppose t-test, correlation analysis. Next, what is variable? Simple in definition, a variable is a characteristics, number or quantity that can be measured or counted. Suppose income is a variable that can be measurable and it has a unit and it varies from this to this range. Suppose income, suppose 100 to 1000 rupees. This is called variable. Types of variable. Variable mainly 2 types. Number 1, numeric and categorical. Numeric are 2 parts, continuous and discrete. Categorical variable mainly 2 parts, ordinal and nominal. Now we discuss the basic definition or basic concept of these variables. First, numeric variables have values that describe a measurable quantity as a number. That means how many or how much. And number variables are quantitative variables. Number variables mainly two types. Continuous variable. What is continuous? A continuous variable is a numeric variable. Observations can take away value from a certain set of real numbers. Examples of continuous variable including height, weight, time, age, temperature, etc. Discrete variable is a numeric variable. Observation can take a value based on a count from a set of distinct whole values. Suppose discrete values including the number registered cars, number of business locations and number of children in a family, etc. Next concept, categorical variable. A categorical variable have values that describe a quality or characteristics of a data unit, like what type or which category. Categorical variables are qualitative variables and tends to be represented by a non-numeric variable. Here in recent studies, categorical variables in basically used in dummy variable concept. And categorical variable two types, an ordinal variable. An ordinal variable is a categorical variable. Observations can take away the value from the logical ordered or ranked. Suppose A, B, C, D. Suppose you have a number of weight, then you ranking this variable is considered to categorical variable. Similarly, nominal variable is a categorical variable. Observations can take a value that is not able to organized in a logical sequences. Suppose sex, business type, eye colors, religion and etc. Now, basically there are two main methods used in inferential statistics. Number one, estimation. Number two, hypothesis testing. Today I discuss hypothesis testings. Before come to the point, now we discuss what is population. Population is a group of phenomena that have some in common. In terms, often refers to a group of people in the following examples. Suppose a registered voters in the country. The total number, all members of the executive committee, all Americans who played golf at least once in a past year, etc. This is basic examples of population. What is sample? A sample is defined as a smaller set of data that is chosen or selected from a larger population by using selection method. What selection methods? This is the sampling method. It's called sample. This is the basic relationship between sample. This is the population set. Here population set, we took 6 samples. This is the population. The right hand side is a population, and left hand side is a sample. These are basic examples. Next, what is parameter and sample or statistics? Parameter is a statistics of population or characteristics of population. A statistics is a characteristics of a sample. That means, suppose population mean, population standard deviation, population variance. Here population parameter is denoted by mu, population standard deviation is denoted by sigma, and population variance is denoted by sigma square. Similarly, in sample statistic, mean x bar, standard deviation s, and variance is s square. Now come to the point. This is hypothesis testing. In hypothesis testing, in this chapter, this is the main point. Here, basically, hypothesis of testing is a technique which helps to determine whether a specific treatment has an effect on the individual in a population. It is a formal procedure used by statisticians to accept the reject and statistical hypothesis. Then, basic questions: what is hypothesis? Basically, this is a predictive statement capable of being tested by scientific methods that relates an independent variables to some dependent variables. And what is independent variable? Suppose y equals to a plus bx. Here y is called dependent variable, x is called independent variable. Similarly, a hypothesis states that we are looking for, and it is proportion which can be put to a test to determine its validity. Suppose a set of data, you collected set of data, what is the validity? We have to prove this validity, this data is always valid, then we can test the hypothesis of testing. Then you can say that my data is valid. Suppose this is basic example, students who receive counseling will show a greater increase in creativity than students not receiving counseling. This is a basic example. The main characteristics of hypothesis. Basically, when we write my hypothesis in my papers on anyone thesis paper, this is clear and precise. Hypothesis must be clear and precise, capable of being tested. Number 3, tested relation between variables. That means this is one side is dependent variable, another side is independent variables. Limited scope must be specified. State as far possible in most simple terms so that the sum is easily understood by all concerned. Next, consistent that most known fact. Next characteristic, responsiveness to testing with a responsible time. Once can stop a lifetime collecting data to itself it. Explain what is claimed to explain. It should have empirical reference. Before discussing in testing of hypothesis, this is the key concept. What is significance level? The significance level is a measure of the statistical strength of the hypothesis test. It is often characterized as the probability of incorrectly including that the null hypothesis is false. What is null hypothesis? Now we come to the next point. Next, power. The power of a set of measures of probability of collecting, including that the null hypothesis is true. Power is not something that you can choose. It is determined by several factors, including the significance level you select and the size of the difference between the things you are trying to compare. Test statistics. The test statistics is a single measure that captures the statistical nature of the relationship between observations you are dealing with. The test statistics depends fundamentally on the number of observations that are being evaluated. It differs from the situation to situations. Distribution of the test statistics. The whole notions of hypothesis rest on the ability of specify exactly or approximately the distribution that the test statistics follows. In the case of this example, the difference between of the means of the approximately normally distributed, assuming there are relatively large number of observations. Now, we know that the sample mean, that means x bar, as an unbiased estimator of population mean. If we selected a random sample from a population, then on average of the value of the sample mean will equal to the population mean is called the data is normally distributed. That means, suppose in a village 100 population is there and population mean of income suppose 100 rupees. You collected 30 population or 30 samples. Here population, here sample mean x bar also 30. That means population mean and sample mean if equal, then the data is called normally distributed. Basically, this theorem is called central limit theorem. Central limit theorem states that the probability of selecting sample value and the population value of mean is equal, and then we can say the data is normally distributed. Next, critical value. The critical value in a hypothesis test is based on the two things. Number one, the distribution of the test statistic and the significance level. The critical value or values refer to the point in the test statistics distribution that gives the tails of the distribution and area exactly equal to the significance area that was chosen. Here, this is how to define critical region. This is a normally distributed curve. In this normal distributed curve, here mean equals to 0 and standard deviation equals to 1. Here z value is minus 1.96. This is the one side is left hand side, one side is right hand side. In the right hand side, this is positive direction. In left hand side, this is negative direction. And this curve is bell shaped. That means you collect the sample, your data is normalized, then you plot your data in a paper, you get this curve. This curve is called basically normal curve or normal variate. How to normal variate? Normal variate can be written as, suppose z equals to x minus mu divided by sigma. This normal variate, put the values of x values and you get the z values, corresponding z values. Suppose when you put x1, you get the value of z1. You put the value of x2, you get the value of z2. Suppose you have took sample, suppose 30 samples you have collected, put the 30's values, x equals to 30, then you can get the value of 30, z equals 30. You plot the graph paper, you get this curve. Then you can say your data is normally distributed. Here, critical region is the end side of the value. That means, suppose z value is greater than equals to 1.96. That means this portion, blue portion in right hand side and left hand side minus z equals to minus 1.96, this portion is called critical region, or z equals to 1.96 or z equals to minus 1.96, this value is called critical values, and blue portion is called critical region. What is p value? The p value of a hypothesis test gives you another way to evaluate the null hypothesis. The p value represents the highest significance level at which your particular test statistics would justify rejecting the null hypothesis. Now, this is the p value design, and this is the critical value, critical region, and start from this is the gap between this portion is, and this is the remaining part is the p values. This is a graphical representation. Now come to the point. This is the main point. What is null hypothesis? Basically, null hypothesis is an assertion that we hold as true unless we have sufficient statistical evidence to conclude otherwise. In null hypothesis, and it is denoted by H suffix 0, if a population mean is equal to hypothesized mean, then the null hypothesis can be written as mu equals to mu 0. An alternative hypothesis, mainly hypothesis is two types. First is null hypothesis and alternative hypothesis. The alternative hypothesis is a just opposite of null hypothesis, and null hypothesis H0 is written as mu equals to mu 0. Then alternative hypothesis can be written as some HA or H1, this is the same thing, mu not equals to mu 0. When mu not equals to mu 0, there are two situations arises. Number one, in alternative hypothesis, mu greater than mu 0 or mu less than mu 0. Level of significance and confidence level. Here, alpha is the level of significance, means the percentage risk to reject a null hypothesis, then it is true and it is denoted by alpha. Clearly, it is taken as 1%, 5% or 10%, whatever. 1 minus alpha is the confidence interval in which the null hypothesis will exist when it is true. Now, risks of rejecting a null hypothesis when it is true. First, this is designation, and supercritical value alpha risks. Alpha means risks, 1 minus alpha means confidence. Alpha value equals to 0.001, that means 0.1%. This is supercritical. Here confidence level is 0.999, that means 99.99%. Here, suppose example, more than 100 million, suppose this is example, large loss in life, that is nuclear disaster, whatever. That means this is now in corona situations. In critical value 0.01, this is a critical, that means 1% risks, that means 99% confidence level, this is a few lost. And important 0.05, that means 5% is risks, 95% is confidence level. This is another interpretation. And moderate, now our research work is moderately work in 0.10 risks, that means 10% risks and 90% level of confidence. Now, type 1 and type 2 errors. Here, this is very interesting. In two situations, null, this is in column, first column is null is true, null is false. And row, accept null, reject null. Here, null is true in first correct, that means both are null hypothesis is correct in the first quadrant. Then null hypothesis true and reject null hypothesis. This type of error is called type 1 error or alpha error. Third quadrant, here null is false, accept null. Here is called this type of null is false but accept null. This type of error is called type 2 errors. And null is false, reject null hypothesis, this is correct, that means this is the correct decision. Here in a normal distribution curve, these are different shapes. In normal distribution curves, in right hand side, this red portion, here HA is more probable, that means this test is called right tail test. Here mu value greater than mu 0, that means this is a value mu 0. Similarly, in second picture, left hand side, this is a red portion, this is a critical value. Here alternative hypothesis mu less than mu value, mu 0. Here left tail test, and both sides, here mu not equals to mu 0. Here there is both sides exist in normal distribution. This is a two direction method, this follows here. This is here null hypothesis, or sorry, alternative hypothesis mu not equals to mu 0. This is the diagram, basic diagram of two tail test at the 5% level of significance. That means here alpha equals to 0.005. That means risk is 5% level, that means risk alpha, this is a risk probability of risk, and 1 minus alpha is the probability of confidence. Here in a normal distribution, there are two tails. One is right direction, that means positive direction, and left direction, this is a negative direction. Here alpha is divided two parts, alpha by 2, that means here alpha equals to, total alpha equals to 5%. Here two sides in two tail in normal distribution, alpha divided by 2, that means 0.5 divided by 2, this equals to 0.25%, 0.25% in both sides. Here rejection region is 2.5% in left hand side, here rejection in right hand side 2.5%. Now accepted region, what is accepted region? In this value, this is remaining red portion, this in under normal curve, the total accepted region or confidence level is denoted by, in previous slide, 1 minus alpha, this equals to 95%. Here in normal distribution, just in two-tail test, the alpha value is divided by alpha by 2. That means here 0.05 divided by 2, that means alpha, one side alpha, left side alpha is 0.025 and right side alpha is 0.025. This is the right tail test. Here level of confidence is 95%, that means alpha value equals to 5%. Here alpha equals to 0.05 and this whole portion in the left hand side from the beginning of the red portion is called the level of confidence level. This tail is right side tail test. Now, what are the basic steps? Basically, hypothesis of testing or significance of testing is a method for testing a chain or claim of or hypothesis about a parameters in a population. Basically, these are 4 steps. First step, first you have to clear the state of your hypothesis. Second step, the set the criteria for a decision. Number 3, compute the test statistic, and number last, make a decision. Here now elaborately we have to discuss the basic steps of hypothesis. Hypothesis of testing procedure. First step, set up a hypothesis. First you have to clear and set up a hypothesis on the basis of the characteristics of the hypothesis. This is a very vital point. Number 2, the set up a suitable significance level. This is 1%, alpha value equals to 1%, 5%, 10%, whatever. Determine suitable test statistics, determine the critical region, perform computation, next last decision making. Basically, this hypothesis of testing and error trial basis we can calculate this, and this is the procedure how to calculate the hypothesis of testing. First, state the null hypothesis HO and alternative hypothesis HA or H1. Test a significance level, that means in stepping 1%, 5%, 10%, etc. Decide a test. Which test you have to apply? Suppose J statistics, T statistics and F statistics. Next, calculate the value of the test statistics. These are directional. Next direction, calculating the value, p value at the given level of significance from the table. We have to calculate the p value table. Compare the p value with calculated value. Suppose your data set is in your hand. You put or you choose null hypothesis or alternative hypothesis and use a significance level. You decide which test you have apply in your analysis. Calculate the value of test statistics, calculate the p values and compare the p values. Compare the p values means from the data set you have to calculate your p values and these p values is compared from the table value. If the p value is greater than calculated value, this is very vital. Here p value is greater than your calculated value, that means we accept null hypothesis. This is number 1 conclusion. And number 2 conclusion, if p value is less than calculated value, you reject alternative hypothesis.